A function f possesses three critical values: x equals -3, x equals 0, and x equals +3. The function's second derivative is f double prime of x equals 10 times the quantity x squared minus 3. Determine if the critical values produce relative maxima or relative minima. Well, to determine this from the second derivative, what we can say is if the second derivative at a particular value is greater than 0, then what that means is we're on an interval that is concave up. And if we're concave up, it's like an upward facing parabola, then any critical number we come across would have to be a minimum. Likewise, if the second derivative is less than 0, then we're on an interval that is concave down, which would look like a downward facing parabola, and so any critical number we came across there would have to be a maximum. So essentially we're just looking to see if the second derivative is positive or negative at these points. So the second derivative evaluated at -3. So this would be 10 times -3 squared minus 3. So this would be 9 minus 3, or 10 times 6, which is 60, but it doesn't really matter if it's what the actual value is. It just matters that it is positive. So it's positive, which means we're on an interval that's concave up, so we have a minimum. So this value is a relative minima. All right, at the next point, at 0, we would have 10 times 0 squared minus 3, which is 10 times -3, which would be less than 0. And so if we have a value less than 0, that means we're on an interval that is concave down. So we would have a relative maxima at any critical value there. Lastly, at x equals 3, we have 10 times 3 squared minus 3, or 10 times 9 minus 3, which is 6, which is greater than 0. So again, this would be a relative minima.